Hello, and let us consolidate what we learned in the previous lesson by solving a few examples. And of course, we're going to take our examples from the book that we have strongly recommended. This is the book, The Mathematical Circles, and let's pick up a few more problems from here on remainders and clear up our ideas that we have learned. So here's the first example. It says that find the last digit of 777 raised to 777. Now, in one of the previous examples, we already interpreted this as the remainder of this number when we divide by 10. So the problem essentially is find the remainder of this number when you divide by 10. So let's start. 777 raised to 777 is basically 777 multiplied by 777 times. Now we already know that we can multiply the remainders. Now the remainder of 777 when you divide by 10 is 7 into 7 into 7 and so on, 777 times. Now with this background, our problem reduces to finding the remainder of 7 raised to 777. Now this is definitely a simplification from here. But now let us see how to tackle the finding the remainder of 7 raised to 777 equal to what? So, like one of the previous examples, let us see various parts of 7 when we divide by 10. 7 raised to 1 gives a remainder of 7. Of course, you know what you are looking for. You are hoping to find a remainder of 1, a power of 7 whose remainder is 1. The same trick. What is the remainder of 7 squared when we divide by 10? This is 9. What about 7 cube? Now we already know how to handle 7 cube. 7 cube is nothing but 7 square multiplied by 7, and 7 square is 9. So it is 9 into 7, which is 63, and we are looking for the remainder when we divide by 10. So this is nothing but 3. How about 7 raised to 4? Now this we will use the same trick, which is that 7 raised to 4 is nothing but 7 cube into 7, and 7 cube is 3, so this is basically 3 into 7, which is nothing but 21, and that is nothing but 1. And you can see that grouping the powers of 7 in groups of 4 is very helpful because the remainder is 1. Now we are in a great position to tackle the remainder of 7 raised to 777 when you divide by 10. Just to remind you, our original problem was 777 raised to 777, and this left a remainder of 7 raised to 777. Now this itself is equal to, let us try to group in groups of 4, because groups of 4 is basically 1. Now how many groups of 4 can we make out of 777, and then what will be left over? Now it is very clear that 776 is perfectly divisible by 4, and therefore this is nothing but 7 raised to 776 multiplied by 7. Now since 776 are perfectly groups of 4, this leaves a remainder of 1 and then multiplied by 7. And this means that the remainder of this when divided by 10 is 7, and therefore the last digit is definitely equal to 7. So with that, we have tackled this problem of finding the last digit of 777 raised to 777. So I hope that this is just a revision of what we have done. Now I'm going to look for another problem from the same book. Now, by the way, this was problem number 30. This was problem number 30 on page 27. So now let's try to pick up another problem from this book. This time it is a much more interesting problem. The problem says that find the remainder of 2, 2, 2, 2 raised to 5, 5, 5, 5 plus 5, 5, 5, 5 raised to 2, 2, 2, 2 when this number is divided by 7. So what is the remainder of this number when you divide by 7? Now the reason I put this line is that we'll tackle this one separately from this. We'll find the remainder of this number when you divide by 7 and add it to the remainder of this number when you divide by 7. So anyway, the problem says that prove that this number is divisible by 7. Essentially, we have to prove that the remainder of this number when you divide by 7 is 0. So let's see. Maybe I shall tackle this problem first, and let's see. Basically, we're trying to find out the remainder of 2, 2, 2, 2 multiplied by 2, 2, 2, 2, 5, 5, 5, 5 times. Now we are pretty much comfortable with what's the first step. The first step is to find out the remainder of this when you divide by 7 and then multiply all the remainders, because multiplication of remainders is allowed. So what is the remainder of 2, 2, 2, 2 when you divide by 7? So let's see, 7 3s are 21, 1, 12, 12, 7 1s are 7, 5, 7 8s are 56. I think I've made some mistake. Let me just check. 7 3 is 21, 1, 12, 7 1s are 7, 5. I'm sorry, this was a horrible mistake. This was 52. Okay, so 7 7s are 49, and this leaves the remainder of 3. Okay, so basically this leaves the remainder of 3. And now we can keep multiplying the remainders, and this is basically 3 into 3 into 3. How many times? 5, 5, 5, 5 times. So we have a new problem which says to find the remainder of 3 raised to 5, 5, 5, 5 when you divide by 7. So this problem, what is the remainder of this number when you divide by 7? Now this problem actually is we have tackled in the morning, and so we should be able to recollect the main steps here. We have to look for powers of 3 and hope that there is a grouping of the powers of 3 when divided by 7 that it gives a remainder of 1. So that will be the grouping for us. So let's try to recollect. Maybe just try to make some space for myself, or use up this space, and then later on we'll tackle this problem separately. So what are the powers of 3? 3 raised to 1 leaves a remainder of 3, but remember that we are dividing by 7. 3 square leaves a remainder of 2. Remember that we are dividing by 7. 3 cube is, let's see, 3 square into 3, but 3 square is 2, so 2 into 3 is 6. So this is 6. 3 raised to 4 is 3 cube into 3, but 3 cube is 6. 6 3s are 18. 18 divided by 7 is 4. And what about 3 raised to 5? 3 raised to 5 is 3 raised to 4 into 3, that is 4 into 3, that is 12, and that is 5. And 3 raised to 6 is 3 raised to 5 into 3, that is 5 into 3, 15, but 15 is nothing but 1. And now we hit the magical number 1. So which means that we should group 3 raised to 5, 5, 5 in groups of 6. So let us actually now divide 5, 5, 5, 5 in groups of 6. So 6 9s are 54, 1, 5, 6 2s are 12, and we have 3, 5, 6 5s are 30, and this leaves the remainder of 5. So having grouped up in groups of 6, we will be left with a remainder of 5. In other words, 3 raised to 5, 5, 5, 5 is equal to 3 raised to 5, 5, 5, 0 multiplied by 3 raised to 5, and 5, 5, 5, 0 is perfectly divisible by 6. I mean, you can easily check, it is definitely divisible by 2 and also divisible by 3, because it's divisible by 6. And now you can see that this leaves a remainder of 1 when divided by 7 multiplied by 3 raised to 5. That is this remainder of this is 1 multiplied by the remainder of 3 raised to 5 when you divide by 7. But this particular answer is staring right here. The remainder of 3 raised to 5 when you divide by 7 is 5, and therefore the remainder of this number when you divide by 7 is 5. And we have solved half the problem. The remainder of this number when you divide by 7 is 5. Now the chances are that this side we are going to get 2 as the remainder, and therefore 5 plus 2 will be 7, which is the same as 0, and which means that this number is perfectly divisible by 7. However, we need to check now. We expect the answer of this to be 2. So I'll do this all over again in exactly the same manner. It's very repetitive, but it's fine. This is a very nice, simple idea, and we should get hold of this idea very well. Okay, so I want to make some space for myself now, and let's try this part of the problem in just about the same way. So this time we are tackling 5, 5, 5, 5 raised to 2, 2, 2, 2. Now you know how this goes. This is basically 5, 5, 5, 5 multiplied by 5, 5, 5, 5, 2, 2, 2, 2 times. So as always, let us see what is the remainder of this when divided by 7, and then let us try to replace that. Okay, so 7 7s are 49, and this is 6, 5, 7 9s is 63, 2, 5, and 7 3s are 21. So this is 4. So the remainder of this when you divide by 7 is 4. So this is basically 4. You can multiply the remainders, remember that. So this is basically 4 into 4 into 4 into 4, 2 times. And this then is the same as 4 raised to 2, 2, 2, 2. And this is a definite simplification from here. And now we need to tackle this number 4 raised to 2, 2, 2, 2. And we know what to do. Let's look for powers of 4. Let's look for powers of 4. Let's look for powers of 4 and hope that we run into 1, right? So that's the strategy. So 4 raised to 1 when you divide by 7 is 4. 4 is to 2 when you divide by 7 is 16 divided by 7, that is 16 divided by 7, that is 2. And what about 4 is to 3? It's basically 2 into 4, that is 8, and 8 divided by 7 is 1, and so we've hit 1 pretty fast here. So you need to make groups of 3. That's the trick here. So let us try to break up 2, 2, 2, 2 into groups of 3. So basically you have to divide by 3. Now this is too easy. We know that 2 plus 2 plus 2 plus 2 is 8. So 8 is the remainder when you divide by 3. 8 is the same as 2. So 2 is the remainder when you divide 2, 2, 2, 2 by 3. So there is no need to do any computation here. So this is nothing but 2, 2, 2, 0 into 4 raised to 2, because 2 was the remainder when you divided this by 3. Now look here, this is again a quick check. 2, 2, 2, 0 is clearly divisible by 3 because 2 plus 2 plus 2 is 6. And so you're left up with 4 square. Now this is definitely going to leave a remainder of 1 when you divide by 7, mind you, because 4 cube when you divide by 7, remember, please don't forget that we are dividing by 7. So 4 cube when you divide by 7 leaves a remainder of 1. So 4 is to this number leaves a remainder of 1 multiplied by 4 square. But the remainder of 4 square when you divide by 7 is right here. It is 2, and I was expecting this number. So this is basically 2. So this is congruent modulo 2. The remainder of this number when you divide by 7 is 2. This was 5, and now you are allowed to add the remainders. So we have 5 plus 2 is equal to 7, which is nothing but 0. So the remainder is 0, and this number is divisible by 7. So this was really a very nice problem that we've used the tricks that we have learned, and maybe we'll do one last problem, and then you can go back to the book and please do master this topic. It is like I said, this problem is, I should have told you the problem number. I think this problem is problem number 33. Problem number 33 on the same page, which is 27. Now, one last problem from page number 28 in this particular idea, and then I think we'll close down today's lesson on this topic. So this problem says, find the last digit of the number 1 square plus 2 square plus 3 square plus so on, all the way till 99 square. So we know the main idea here. The main idea here is to find out the remainder of this number when you divide by 10. So now this actually lends itself to a very quick analysis. We are trying to find out the remainder of this sum when you divide by 10. And what you first need to notice is 1 square plus 2 square all the way till 9 square. Now you don't need to worry about numbers of this kind, because these numbers when you divide by 10 will leave a remainder of 0. So don't have to worry too much about 10 square, 20 square, 30 square and so on. But notice something very nice. When you come to 11 square plus 12 square plus 13 square plus so on up to 19 square, what you realize is 11 square is nothing but 1 square, and 12 square is nothing but 2 square, because we are talking about remainders when you divide by 10. 13 is the same as 3, and 13 square is the same as 3 square. So again we see that this is repeating, and so the same set of numbers has occurred all over again. And of course the same thing will happen when we talk about 21 square plus so on up to 29 square, and once again we don't really care about 30 square. Now once again this number is the same as 1 square plus 2 square plus so on plus 9 square. In a sense, these numbers are repeating all over again and repeating all over again, and they will repeat 10 times. So this problem is nothing but 10 times this remainder of 1 square plus 2 square plus 9 square. But notice now that whatever this number is, we don't really need to worry about it, because this is 10, the remainder is 10 times the remainder of this, but the remainder of 10 when you divide by 10 is 0. So it is 0 times something, the remainder of this number when you divide by 10, and this is obviously 0, and therefore we quickly conclude that the last digit is equal to 0. So this was turned out to be a much easier problem than it looks. So we really need to keep your wits about yourself and look for simple patterns. But it was a very nice example, and I think I hope that you feel much more comfortable in this topic. The book will definitely make you much more comfortable by giving a lot of problems, but don't forget, most of the answers, if not all, are there in the book. There's nothing to worry about, and you can always look at the answers if you're badly stuck. But this is the book that will help you to master all the important topics, and we'll race through the main ideas in the next few days. So please be very optimistic of getting through with all the basics very fast, but you need to practice. All the best.